Welcome to Science Weekly, your source for the biggest breakthroughs shaping our world. It's late January 2026, and we have a packed show for you, from the depths of the cosmos to the tiniest pores on a leaf. Let's dive right into this week's top science stories. First up, we journey to the very edge of our understanding of the universe. For decades, scientists have been puzzled by the cosmic giants, dark matter, and dark energy. Together, they make up about 95% of everything out there. Yet they've remained completely invisible to us now. A groundbreaking international collaboration using a new generation of incredibly sensitive particle detectors deep underground may have just caught the first glimpse of an interaction. Between them, preliminary data suggests that dark matter isn't just a passive scaffold for galaxies. It might be actively influenced by the push of dark energy, the force driving the universe's expansion. If these findings hold, it's not just a small step. It's a giant leap that could rewrite our cosmic rulebook. This discovery could help us finally understand why the universe's expansion is accelerating and what the ultimate fate of our cosmos might be. The team is now working around the clock to verify their results, but the excitement in the astrophysics community is palpable. We might be on the verge of solving the biggest mystery in modern science. Next, we turn our attention back to Earth and a major breakthrough in our quest for sustainable energy. The dream of a world powered by renewables like solar and wind has always faced one major hurdle: storage. How do you keep the lights on when the sun isn't shining or the wind isn't blowing? Well, a team of chemical engineers has just announced a game-changing solution with bromine-based flow batteries. These batteries have incredible energy density, but they've always been held back by a critical flaw: the highly corrosive nature of bromine, which eats away at the battery components over time. But not anymore. Researchers have developed a revolutionary chemical capture method using a special organic molecule that essentially cages the bromine, neutralizing its corrosive effects while still allowing it to participate in the energy reaction. This simple yet brilliant innovation could lead to batteries that last for decades, not just a few years, making grid-scale energy storage dramatically more affordable and reliable. Imagine entire cities powered for days on stored renewable energy. This isn't just an improvement. It is the missing piece of the puzzle that could accelerate our transition to a truly green energy grid from large-scale energy. We zoom into the microscopic world of plants. We all learned in school that plants breathe, taking in carbon dioxide and releasing oxygen. But we've never been able to watch this process in real time at the level of a single pore. Until now, using a new non-invasive imaging technique, scientists are literally watching plants breathe. These high-definition videos show the stomata, the tiny pores on a leaf's surface, opening and closing in response to light, humidity, and CO2 levels. By tagging carbon and water molecules with fluorescent markers, they can track their exact journey into and out of the plant, moment by moment. This isn't just beautiful to watch. It's vital information for our future food security. By understanding precisely how different plants manage their resources, we can develop new crop varieties that are far more resilient to drought and changing climate conditions. We could engineer crops that are more efficient at absorbing carbon, helping in our fight against climate change while simultaneously increasing yields. It is a stunning example of how observing the smallest details of nature can help us solve some of the biggest challenges we face. Now, we head out to the open ocean, where scientists have uncovered a new and alarming phenomenon they're calling underwater darkness. We often think of the ocean's surface as being bathed in sunlight, which is crucial for the phytoplankton that form the base of the marine food web. But recent data from a fleet of autonomous ocean buoys has revealed something startling: sudden, prolonged episodes where the upper ocean becomes incredibly murky, blocking almost all sunlight from penetrating. These events are not caused by storms or sediment runoff from rivers. Instead, they appear to be linked to unusual algal blooms that create a thick, light-blocking layer. When these darkness events occur, they can last for weeks, causing a catastrophic collapse of the local marine ecosystem. Phytoplankton die off, and the effects cascade up the food chain, impacting everything from tiny zooplankton to fish and marine mammals. Scientists are now racing to understand what triggers these blooms and whether their frequency is increasing due to climate change and ocean warming. This discovery adds a new, urgent dimension to our understanding of the threats facing our oceans. Finally, we look at how our planet's climate systems are becoming more interconnected, with potentially devastating consequences. You've probably heard of El Niño and La Niña, the cyclical warming and cooling patterns in the Pacific Ocean that can influence weather worldwide. New analysis of decades of satellite and climate data has revealed that these cycles are becoming extreme and, crucially, are synchronizing with other climate patterns across the globe. What does this mean in practice? It means that a severe drought in Australia, driven by La Niña, is now more likely to occur at the same time as massive flooding in South America. A heat wave in Europe could coincide with a failed monsoon in India. This climate synchronization puts immense strain on our global food supply, emergency response systems, and economies. When multiple breadbaskets of the world fail at once, the ripple effects are felt everywhere. This research is a stark warning that climate change isn't just about making things warmer. It's about fundamentally rewiring the connections within Earth's systems, creating a more volatile and unpredictable world for us all. And that's a wrap for this edition of Science Weekly. From the potential discovery of dark matter's secrets to the alarming synchronization of our planet's climate, this week has shown us just how interconnected everything is. From the cosmic scale down to a single plant cell, the challenges are immense, but so is the power of human ingenuity to understand and innovate. Thanks for joining us. Don't forget to like, subscribe, and hit that notification bell so you never miss an update from the frontiers of science. We'll see you next week.